All right, so if you've come to this video, then what you're looking for is some naming and formula writing review. So naming and formula writing review. Okay, and the biggest thing when we start to think about naming compounds and writing the formulas for them is whether or not they're ionic or covalent. And so we need to recognize, is it ionic or covalent? And I can't stress enough, I think about my little periodic table. If we've got our little zigzag here, if they are both nonmetals, if they are both to the right of this little stairway, then both here, then it's going to be two nonmetals is going to be covalently bonded. Okay, if you're dealing with something on this side, which are all of these, basically, you know, you get your 3+, basically you have all your positives, a positive with your negatives, which of course the negatives are over here, then you have an ionically bonded substance. The difference, of course, between both of them is a covalently bonded substances, you need to use prefixes. And to me, when you see a name that has prefixes, it's pretty easy to write the formula. You just write whatever it is. But ionic, no prefixes. It's a balancing of charges. Okay, so let's go ahead and take a look at some of these examples again, just as a little bit of a review. Let's say we have, well, let's do a few of these. CaNO3 examples here. Another one, let's say Cu2O. How about C3O5. And how about another one? How about MgOH2? Okay, so if I look at these, let's do a few of these. First of all, as soon as I see that NO3, I should know it's an ion. Why do I know it's an ionic one? Because this is a polyatomic ion. So if it's a polyatomic ion, then we're dealing with an ionically bonded substance. So, naming ionic compounds, first one is the same name, calcium, and then the second one, whatever that ion is, nitrate. Why do I know it's nitrate? Because that's at NO3. And again, just as a quick review, let's see them. We have ammonium, we have hydroxide, nitrate, acetate, sulfate, carbonate, and phosphate. All right, so those are our polyatomic ions. Calcium nitrate's that top one. This next one here, Cu2O, copper something oxide. Why do I say something? Well, because I know when I look in the periodic table that copper is in the middle. And remember, in those middle, those transition metals, they're always positive, but they can change. Copper's with oxygen, so it's a ionic compound. It's a transition metal with oxygen. So what is the charge on copper? In order to figure out what the charge is, again, it's a question mark right now, we look at O. O has a charge of 2-. We only have one O, so since we have only one O, it's a 2- total. We have 2 Cus, so since we have 2 Cus, then each of them must be a 1+. Why? Because it needs to balance off that 2- charge on the negative ion. So copper 1 oxide. Notice people see that 2 there and they immediately start thinking, oh, it must be copper 2. No, it's copper 1 because it's the charge, not how many you have. Okay? The next one. This next one, carbon and oxygen are both in the, And again here, they're both in this right side. They're both non-metals. So this is going to be a covalently bonded substance, so we must use prefixes. Tricarbon. And if you called it pentaoxide, that's fine, but pentoxide. Again, we're using the prefixes because they're both in the right side. And the last one, well, notice the OH, which is a polyatomic ion, which means it's an ionically bonded substance. Magnesium hydroxide. Magnesium hydroxide. OH is hydroxide. I wanted to do this one as an example because I wanted you to see you need to put the parentheses around the OH. Sometimes people forget that. They put OH2 like this. Notice that this means I have two H's, but it doesn't mean I have two O's. This 2 goes to both the H and the O, which makes sense, right? Because if magnesium is a 2+ and each hydroxide is a -1, notice we need 2 of the whole thing to balance off the 2+ charge. So those are some examples, again, of some of our formulas.